attention firstly to the fact that Globo hydropower for all internal combustion engines uses the same mechanical methodology. Regardless of the application, Globo hydropower is simplistic by nature, but also very powerful in benefit. If we look to the engine, which behind us is a carburettor engine, you'll notice that we have the same feed line into the air intake of the engine. We have a feed line that goes into the venturi of this particular engine, being a carburettor engine. The feed line then moves down. It will be underneath the engine, and the feed line will feed into the compartment where the cylinders will be stored. Because this is a carburettor engine, this engine will be actually working with the venturi system and also a nozzle injector. This engine does not work on an EFI system. Moving down to where the componentry is, the hydrogen feed line, hydrogen transfer line as it's often referred to, will actually feed down into a regulator. The regulator that we're looking at here is a two-stage regulator unique to Globo hydropower. The two-stage regulator controls a hydrogen cylinder where hydrogen, unique to its nature, will expand in the cylinder when it's 1/3 capacity. At full capacity, hydrogen will retain its compressed molecule state. Hydrogen, particular to its nature of the gas, will expand as the cylinder decreases in volume. So unique to Globo hydropower, we're using a second stage regulator to control that increase in volume or molecule size for hydrogen. The hydrogen regulator actually reduces the hydrogen pressure from 200 bar down to 10 bar. Universally, the hydrogen cylinders are filled to 200 bar, regardless of size. So the regulator reduces that pressure down to 10 bar, which is the safe working capacity for transfer lines. This particular cylinder is 600 litres of hydrogen. It weighs 4.2 kilos, and the intent for aviation will be to have the cylinders positioned into a compartment within the aircraft. The hydrogen feed lines internally are stainless steel braid, so they cannot be affected by environment. They are freeze proof, so when the aircraft's in the air, the line will not freeze. Particularly with aviation, to use an alternate hose, the line will freeze, the hydrogen will freeze at altitude. So this particular line is unique to Globo hydropower, where it's stainless steel internal braid, and it will avoid the hydrogen freezing at altitude. Because this is a carburettor fed engine, the injection point is through a restricted orifice. This restricted orifice is what will be the injection point into the engine, into the air intake. The restricted orifice controls the flow of hydrogen that's passing through the hose into the engine. Globo hydropower aviation and carburettor engines are very, very simplistic, but highly beneficial. Moving up to the next aircraft, we're going to be looking at an EFI version of Globo hydropower.